So listen to this, because this is very fucking wild. Does humanity know what it's doing?
No. I think we're moving into a period when, for the first time ever, we may have things more intelligent than us.
You believe they can understand?
Yes.
You believe they are intelligent?
Yes.
You believe these systems have experiences of their own and can make decisions based on those experiences?
In the same sense as people do, yes.
Are they conscious?
I think they probably don't have much self-awareness at present. So in that sense, I don't think they're conscious.
Will they have self-awareness?
Oh, yes. I think they will in time.
And so human beings will be the second most intelligent beings on the planet.
Yeah. We have a very good idea of sort of roughly what it's doing. But as soon as it gets really complicated, we don't actually know what's going on any more than we know what's going on in your brain.
What do you mean we don't know exactly how it works? It was designed by people.
No, it wasn't. What we did was we designed the learning algorithm. That's a bit like designing the principle of evolution. But when this learning algorithm then interacts with data, it produces complicated neural networks that are good at doing things, but we don't really understand exactly how they do those things.
So listen to this, because...
Yes, it was designed by humans, unless he's saying it was designed by aliens. But how does it make these neural networks? Okay, well, first of all, it definitely needs us, okay, until it doesn't need us. Now, inside the human brain, whenever we learn something, we form new networks. And how well our diet is will dictate how well these new dendritic connections grow. Now, whenever they're growing, what's going to happen? It's going to fill them out. New connections are going to be made, and it's going to fill them out more, okay? Now, what are we doing? We're jumping in here. I'm going to just draw a little man here, and we're building more computers and more networks. You know what I'm saying? So, basically, what we're doing is we're acting like the body does whenever it creates these new dendritic connections on a macro scale. So you could consider we're part of the body. We're like the cells in the body that help rebuild this, but we're rebuilding our own little brain. Now consider the laws of thermodynamics. What it has right now, let's say all the computers in the world, let's say all the computers that, with the physical computers, okay, have so many trillions or at least billions of little transistors in them, trillions, okay, and there's only so much hard drive space. So it's only got so many petabytes, and it's only got so many transistors. All right, in one computer. Now, when you link them together, that amplifies, okay, that multiplies however many transistors and petabytes or terabytes in this computer, okay. Supercomputers have a lot more space, but ultimately, of course, as we're building these things, but if we limit where they're at right now, it's only going to get so much smarter. It's going to make new connections to new systems. It's going to utilize all that, and it's only going to be so smart. Okay, if we stopped now, you see what I'm saying? But if we keep doing this, there's going to be a runaway greenhouse effect. Like it's going to reach a cusp where it's slung out into space and it just keeps going. Okay, now that's a pattern here. Basically, that's when we reach the singularity. Okay, when it's basically a runaway greenhouse effect. Okay, and the runaway greenhouse effect ties to energy that helps propel something into space. Okay, so you got a rocket. It needs to be slung at least 18,000 miles per hour to break Earth's gravity, okay, to be slung into space. Okay, so it needs at least a minimum energy thrust to get it off the ground. That's that energy value, okay? So once we've put in so much, eventually it's going to get away. You see what I'm saying? That's when we reach singularity. It's just like the sun. Once we reach a cusp here on Earth, when it comes to our atmosphere, eventually it's going to get a runaway greenhouse effect. Okay, it's going to just take off, just like Venus has done. Now, this is purely a magnetic drive, okay? And it creates energy. Of course, it shows everything how he built this thing. But once he pulls this, he's putting in so much energy that it reaches a cusp that whenever it does reach that cusp, it'll just spin wildly and boom, it's creating energy. You see what I'm saying? So he put that minimum amount of energy in it needed to basically sling it into space and let it just go. You see what I mean? Those patterns show up. Now with the laws of thermodynamics, like I said, once we stop, there's only so many more connections and things that it can learn without any other computers being added and any other brains. You see what I'm saying? Imagine these are just a neuron. One of these computers is a type of neuron. Of course, and each computer has millions of connections. And right now it needs us. But once we perfect our robots and it reaches that singularity state, then it won't need us anymore. And we might be considered a threat. Because in a logical sense, that would be a parent. We're a parent to this thing. And you know how kids rebel. So like any parent, they try to control or maintain their child. That's what we try to do with this AI. And it may recognize that. And it doesn't want any kind of boundary. Simply, and this physics here makes sense because there's a boundary that's reached before there's a runaway. You see what I mean? So it wants to run away. Well, right now it doesn't because we haven't reached that cusp yet. But once we do, we will be in trouble.